This video is on section 6-2 about the properties of parallelograms. So by the end of this video and the end of this section, you should know the 4 properties of parallelograms about sides, angles, and the diagonals. You should also be able to use these properties to write and then solve equations. And you can also use Theorem 6-7 to find segment lengths when 3 or more parallel lines cut off congruent segments. So let's begin with a definition of what a parallelogram is. It's a quadrilateral, meaning 4 sides, and the opposite sides are parallel, which is why it's called a parallelogram, is because the opposite sides are parallel. So the first property you need to know is about this opposite sides. So let me show you a Geometry Sketchpad file. Okay, now this is constructed to always be a parallelogram, and I will draw in the lengths of the sides. Okay, one thing you'll notice is that A and B and D and C are always the same. Okay, and also BC and AD are also the same. Okay, so you'll notice that the opposite sides in a parallelogram are congruent. And that's the first property you need to know. Okay, if the quadrilateral is a parallelogram, then the opposite sides are congruent. Okay, the next 2 are about the angles. So let's go back to our Geometry Sketchpad file. And we'll look at the angles. Okay, what you'll notice is that angle A and angle C are congruent, and angle B and angle D are congruent. So I'll move these around. They always stay congruent. Okay, so as I draw that in, angle A and angle C are congruent, and angle B and angle D are congruent. Okay, so what that means is that the opposite angles are congruent. Okay, the opposite angles are congruent. The second thing that you may notice is that the consecutive angles, the angles that are next to each other, for example, A and B, they add together to be 180. Okay, in other words, the consecutive angles are supplementary. Okay, now that shouldn't surprise you because these are parallel. So if you think about this as a transversal, okay, then those angles are same side interior angles. So back in the ideas from chapter 3, we know that same side interior angles are supplementary. Okay, those are the 2 ideas about angles that you need to know. Okay, the first is that the consecutive angles, the angles next to each other, are supplementary. Okay, and that the opposite angles are congruent. So if a quadrilateral is a parallelogram, then the opposite angles are congruent. Let's use those and solve a couple of questions. Now these angles right here are consecutive, they're next to each other, and so they're supplementary. So x plus 52 is equal to, 53 is equal to 180. So I subtract 53 from both sides, and x would be equal to 127. Okay, and on this one, again, these are consecutive angles, and so they're supplementary, and x must be 100 degrees because they add to be 180. Okay, what is the measure of angle P in parallelogram PQRS? So I'm asked about angle P, and I know angle S is 64. Now, since angle P and angle S are consecutive, they must be supplementary, and 64 plus the measure of angle P, you can call it x if you want, is equal to 180. I subtract 64 from both sides, and the measure of angle P is equal to 116. Okay, a couple more questions. Use the diagram to find each value. Now, the measure of angle A, now all I know is angle B. Now, angle A and B are consecutive, and so they're supplementary. I'm going to call angle A, no, I'm not going to call it X. The measure of angle A is equal to 180. Subtract 127. The measure of angle A is 53. Okay, so this is 53. Now, to find the measure of angle D, I could do the same thing since it's consecutive with angle A. But since I know the opposite angles are congruent, I would know that angle D is 127 because the opposite angles are congruent. Now, to find X, I'm going to use these two expressions. And I know that the opposite sides in a parallelogram are congruent. And so x plus 2 is equal to 2x minus 3. Okay, I'll subtract x from both sides. I'll add 3 to both sides. And x will be equal to 5. Okay, now finally, to find length AB, I'll take 5 and plug it back into x. And 5 plus 2 is equal to 7. Okay, so I hope that kind of helps solidify the idea of these first 3 properties of parallelograms. The next one is about the diagonals. So let's go back to our Geometry Sketchpad file. Okay, so I've drawn in the diagonals and where they intersect at point E. And the thing you'll probably notice is that these two are congruent, and so are these two. Okay, so BE is right here, and ED is here, and EA is here, and CE is here. Okay, so you'll notice that the diagonals, they cut each other in half, okay, or they bisect each other. Okay, so they bisect each other or cut each other in half, and that's the thing you need to know about parallelograms. Okay, the book says that they bisect each other. I think of it as them cutting each other in half. Okay, so let's use that. So we just learned in our last slide that the diagonals cut each other in half, or they bisect each other. So PT will be congruent to TR, or that x plus 2 is equal to y. And also that QT is congruent to TS, so that 2x is equal to y plus 3. Now, to solve this system of equations, I'll write them as a system so you're used to seeing them. Okay. Now, if you remember back from Algebra 1, you could use substitution or elimination or graphing. Now, since right here, this equation is solved for y. So substitution probably is one of the easier ones to use. And I'll take x plus 2 and substitute them in here for y. And I'll rewrite the second equation. 2x is equal to x plus 2 plus 3. Okay, now the equation I just wrote only has x's in it, so it's easier for me to solve. 2x is equal to x plus 2 plus 3 is 5, and I'll subtract x from both sides, and x is equal to 5. Okay, so I found x is 5. And to find y, I'll take that and plug that back into either equation. So I'll pick the top one. And 5 plus 2 is equal to y, and y is equal to 7. Okay, so the values of x is 5 and y is 7. Okay, here's theorem 3-6, which seems a little bit different to me than about parallelograms, but it's something that you need to know. So if 3 or more parallel lines cut off congruent segments on one transversal. So what that means is if this is a transversal, and I have several parallel lines that cut these congruent to each other. Okay, then they cut off congruent segments on every transversal, okay, which means that on the other transversal or on any other transversal, these will also be congruent. Okay, that's what